Alright, so we're going to go ahead and talk a little bit about vectors and how vectors affect boat control and boat movement. So we're going to start with our river here. We're going to need some features on the river. So let's add a couple of rocks, a little bit of water to those rocks. We can see that they're creating some nice pillows, a couple of eddy lines. Obviously, in this case, the river is flowing from the left to the right. Those two rocks are going to create a constriction. That constriction is going to have kind of a nice downstream tongue or V and a wave train at the bottom. So that looks like a fun little feature to play on. It looks like we got a strainer in the river as well here. That strainer is going to be something we're going to want to avoid. Obviously not a safe place to be in a raft. And then we'll add a couple more features down here. Another couple of rocks, some smaller ones on the river on the right, and a bigger one on the river on the left, a big wave train and kind of a tongue there and some eddies. So a little bit of nomenclature for us, river left versus river right. So the river left is going to always be what would be on the left-hand side if you were facing downstream, moving with the current downstream. So river right is the same there as well. So here we can see a vector. So one of the things to remember on any river is that the current is not always traveling directly downstream. In this case, that first arrow, you can see that it's traveling downstream. We're going to continue. It's going to go in a straight line. It's any other object obeys the laws of physics. It has speed or momentum in a given direction. It's going to continue in that direction until something acts on it to change. In this case, the river right riverbank. You can see the river current rebounds. That vector hits the wall and bounces off. It goes off at a similar angle as you would expect a billiards ball to go off. Right? Here it is headed towards our strainer. Bounces off that wall again. Towards that rock, kind of is pushed up off that rock as part of that pillowing action, that constriction that's helping to create that wave train there, and then continues on down the river. So let's say that we were in a raft on the shore on River Left, and we've stopped to have lunch, or to scout this rapid, or to have a bathroom break, or whatever reason we've stopped, and we're looking at trying to get ourselves set up here. What we're going to need to do is we need to move out into the main part of the current to avoid this rock on the river left. So we're going to get an all-forward paddle from our crew, a nice easy one. You can see that arrow, the orange arrow, is going to always be our forward speed with the raft. Next, we're going to have to account for the fact that the river is traveling downstream, which is this blue arrow in this case, right? So adding those two vectors together, we get this green arrow, which is our resultant path of travel. So in this case, a raft is going to end up right here. Not a big deal. We do this all the time, where we'll approach a rock using forward direction in one way, and then quickly spin the raft using like a draw stroke in this case, or using our crew to help spin the raft, get us pointed downstream, spin off of things. So we're in the middle of the current again, go through some fun waves. Woohoo! Everybody's having a great time. And the raft ends up pretty close to the river right shore there. Again, get the boat spun. All right, we're going to have a resultant forward momentum there. We want to move away from that river right bank. We've got the river current in this case is going to be pushing us into the river right bank before it bounces off. We don't want to hit that. Our resultant path of travel is such that the raft would be carried into the current that is bouncing off and headed back towards the center of the river. So we end up back in the center of the river. Oh man, that was super fun. Everybody's giving each other high fives. I'm not paying attention to the raft guide, or maybe the river's just pushier today than it has been in the past. The flow is higher. Whatever it is, I end up a little closer to that strainer than I want to be. So close to that strainer, I call for an all-forward hard from my crew. Get a big forward momentum push, right? Got to continue to account for the vector for the river. Resultant path of travel is away from that strainer, right? We're just going to barely miss it and dodge it. However, that does then put us pretty close to that river left bank. We're going to end up right on top of this rock, again, celebrating the fact that we avoided a certain death with that awful-looking strainer there. I don't want to end up on that rock, so do a spin move, point away from it, call an all-forward hard, but I haven't really anticipated how fast that downstream current is relative to how strong my crew of paddlers are. So the big current there, that constriction, we often see increase in flow, increase in speed of the river. The resultant path of travel there puts us on top of that rock, which is not where we want to be. It's a very muy malo thing. Let's look at that again. So one of the things that we can often do is we're not beholden to making our moves all perpendicular to the current. So we don't always have to be at right angles to things. We can set up at, say, a 45-degree angle to the current. So let's see what that does. So we've got our forward paddle. So we have our direction of travel in this orange arrow again. We have our downstream current. It's, again, pretty strong downstream current. But because some of our forward moment or forward speed is headed upstream fighting that current, we're not going to move downstream quite as quickly. We'll move side to side. Right? So our resultant path of travel is a little bit more to the left. So I've bought myself some time. I'm able to like move away from that rock. It makes my clients think, oh yeah, it was really scary and fun. Part of giving them a good ride. And it's actually a move that we're going to talk about in the next section, which is called a ferry. It's where we use the vectors and the currents to go ahead and do some of that. Woohoo! Let's go down this wave train, guys.